record this here, and we can get started. Okay, so business math, late at night too. Oh, well, maybe it's good for some of you, but I don't know. I'm just so tired already. But that's okay. So I'm Emily Lee. I got married. My parents aren't that cruel. There's 5 E's in there. But used to be Gustafson. So if you see Emily Gustafson anywhere, that's me too. I've got my double identities. Okay. And we're doing business math. So math 114. I guess I can put that up here as well. Oops. And just some the usual information, right? So my email follows the same structure as all the other emails around here. elee@okanagan.bc.ca. And I'll give you guys my cell phone number too. I was hoping to have something like a group messaging service without being Messenger. That's the obvious choice, right? Everyone's kind of on Messenger to some degree. Just doesn't feel very professional. So I don't know. I was kind of toying with WhatsApp or Line. I don't know. Is anyone on either of those two? Just a couple of head bobs. Yeah, kind of. Everyone's kind of like, yeah, I've heard of it. Good enough. But for now, I'll just use my cell phone. You can text me if you have questions. I find that it's easier to just text if you have questions instead of writing an email. Right? It can be a little bit quicker, a little bit more rapid fire. You can send a picture of what you're working on. Kind of, we can go back and forth. I can send you, more importantly, I can send you a picture of what I've done, and then you can figure it out. So my cell is 250-864-8386. This, I'll make a note here. Oops. My writing really went out the window over the break. I came back yesterday and tried to write something, and it's like, couldn't write anything. Even worse on the iPad. As you probably noticed, right? I'm hosting a meeting on Zoom. So throughout the term, all our lectures will be on Zoom. So if for whatever reason you can't make it to class and you still want to kind of join in remotely, then you can. So Zoom is like any sort of meeting software, Skype, GoToMeeting, all those fun things. So you don't need to have an account or anything. All you need is my meeting ID, and that's our Zoom room. Fun to say. So this is also the Zoom meeting ID. That's kind of good to know. Good to know for 2 reasons then. It's my cell phone and it's a Zoom meeting ID. So we'll I'll show you. I posted a link on Moodle just so you can kind of go through the link. Not 100% sure if it works because I have the app installed everywhere, so it just keeps opening in the app. You should just be able to go through a browser, but I don't know. Oh, and my office is in C104. Now it's a shared office, and the people I share, I'm kind of a newbie, so I don't get any say in this. They covered all the windows, and that's how it is. So you can't tell if anyone's in there. Just knock if the door is closed. We try to keep the door open if someone's in there. Sometimes I close it. I'm guilty, to keep the warmth in. that that's all. Okay, so the light is always on, so that's not helpful, but just give it a knock. And if I'm on campus, then you can stop by any time for questions, right? You don't have to wait around for office hours. Or like I said, you can text me or whatever. Or if it's kind of a bigger question, then I haven't had this happen yet, but we could technically meet on Zoom, right? Because that room is always open for us. Okay? So you've got options. Okay. Oh, any other contact information that I should be sharing with you? No. Okay. So, well, then I can think of. Most importantly, before we start anything else, for Wednesday, I need you to acquire the textbook. I don't care if you buy it at the bookstore, borrow it from a friend or whatever, just have a textbook. They used to be blue, so even if you buy a blue one, then that's fine. Right. I saw one laying around like in the student services building for a long time. They're just kind of around. So you don't necessarily have to buy one unless you want it to be nice and clean. But looks like this. There are other books as well. There are 2 other books. You don't need to buy those. One is the full solutions manual, and the other is, I think, just practice tests, I think. I don't even have them, so I don't know. But those are just optional. This is the only one that you need. It's kind of a nice, I don't know. Students think it's too brief. I like how brief it is. And then it just has tons of practice problems. So it depends on what you like, I think. But I will be referring to examples in the textbook. Right? I'm just kind of talking about the textbook, so it's good to have it. Okay. I don't think it's too expensive. I think it's around 30 or something like that. So here's the big ticket item. I need you to buy a calculator. Looks fine on the outside, but I think it's almost $50. Why? You gotta wonder. It's these little white buttons, you see. Well, maybe you can't see. Those are why we pay the big bucks. In general, it's actually not that good of a calculator. But it is the one that we have to use. It's the one that business requires that we use. And so, gotta have it. Okay. I'm sure you could probably kind of source one, right? If someone's taken the course before and they don't need it for this term, that kind of thing. I don't know, get creative, guys. I also know that you can borrow them from the library. Feels risky for test days, especially, but they are kind of on loan at the library. I don't know how many though. Okay. So, most importantly for today, I'll say for Wednesday, you need to, 1, buy the textbook. I'll put quotes around it. Buy it. I don't mean steal it. I mean, do whatever you gotta do, okay? Great. So, buy a textbook. And it is called The Mathematics of Finance by Joe Hobart, who is our department head here at the college. So, yellow or blue, that's an old edition. But I really don't think things change that much. Okay, so if you come across a blue one, that's kind of an older edition, should be fine. Second thing I need to force you to do while you're still fresh here is buy the calculator. Buy the calculator. It is the TI, so the Texas Instruments BA2 Plus calculator. I think I've even seen a professional one. You don't need that. I think it's more expensive. Look nice. Okay. I do suggest that you kind of go out and buy it right away. Take some of the sting out. But also, so we get used to working with this calculator, even though we don't need it for the functions until later in the term. Right, probably until test 2. Okay, we're gonna have 3 tests. Okay, so because I hadn't said that yet. Right, so we won't use it until about test 2. Okay, halfway through the course, but at that point you'll be very glad to have it. Okay. So that's what I need you to do for Wednesday, okay, one way or another. So this course can be kind of tricky, right? It's kind of some weird stuff. Maybe you're not too keen on math or what have you. So there are resources, and I just want to point you in their direction so that you're aware that they exist. So some resources that you have. The first one that's really good is the Learning Center, of course, where they offer free tutoring. There's lots of business math tutors there. Okay. So the Learning Center has free tutoring. I'll also give information about, once it kind of comes my way, about the SL sessions. Now, we don't have an SL leader in this class, right? But we're all covering the same material. And so, so going to the SL sessions would be really beneficial, even though they're not in this class. Do you guys know what SL leaders are? No? Judging by the lack of nods, it's a no. So an SL leader is someone who's taken the course before and presumably did okay in it. No, they did well in it. And now they go and they sit in on someone's lectures. So they kind of sit in with you guys in a class, and then they have practice problems that they think will help you out, right? And so they kind of know where you're at in the course, and then you know, they host these kind of tutoring sessions. Okay? So really good to have that insight of having taken the course and seeing how the instructor is kind of structuring the questions and being like, oh, okay, I know what type of question they're going to ask, right? That kind of thing. So those are the SL sessions. I think they would be most beneficial if you go to them kind of throughout the term, right? Not just at the end, but obviously helpful at the end too. Okay. So as I have information about the time and the place of these SL sessions, then I'll let you guys know. Because sometimes it can be intimidating to come talk to me about questions, or I don't know, just don't want to talk to me. I don't know why. But of course, you're always welcome to come ask me questions too. Okay. And finally, of course, our fan favorite, Khan Academy. Can't go wrong. You've probably heard of Khan Academy, but Khan just kind of goes through concepts in kind of bite-sized portions. It does require that you know what to search for, which can always, or can almost be the hardest part, right? what is it that I'm not understanding, right? But once you kind of know what you're looking for, then Khan Academy is really good. Okay? So as far as how I structure my lectures, you'll see, we're gonna do this. So I post or write all my notes up here, and then I'll post this PDF on Moodle. Okay, so you'll always have the notes available too, even after class. And if you do miss a class, I know you guys won't, but just in case, then the bare minimum that I'm expecting is that you've read these notes, right? Because often what I'll do is, if there's kind of important information, I'll put it at the top, right? Just so you can't miss it. For example, assignment blah, blah, blah has been moved to this date, right? That kind of thing. So you want to stay on top of that. Okay. And these notes and my voice are being recorded. And what I do is I'll post those videos on YouTube. Okay. So all my lecture videos will be on YouTube, and it'll just be exactly what you're seeing on the screen, and my voice. Okay. Gets kind of long and boring, but on the plus side, someone told me that I guess YouTube just automatically subtitles it. Kind of fun. So kind of helps to absorb. And I guess they do a pretty good job of subtitling me. So that's good. So you'll have the notes as a PDF. You'll have the lecture videos. You're able to join in online. Okay. There's no reason to fall behind on the material. Okay. On Wednesday, I'll give you guys a term schedule, right? So what we're going to be doing every day, and just so you can kind of have an overview of where we're headed. Sorry I didn't get it to you today. I meant to, but I'm teaching two sections of stats, and we're trying to figure some stuff out. So got out of hand. But on Wednesday, I'll give it to you guys, and you'll have an outline of everything that we're doing. So, we're gonna do a mix of hand-in assignments and Moodle assignments, mostly Moodle assignments. Okay. I'm waiting to hear back on the final amount that the assignments can be worth. Usually I do 15, but there's talk of cutting it down to 10, so stay tuned. But not a huge chunk of your mark anyways. So they'll just be, I like to keep them short, quick little Moodle quizzes. You'll have a week to do them. So regardless of if it's a Moodle quiz or a handing assignment, you'll always have a week at least to do them. And Moodle quizzes, we'll do tests. So before each test, we're gonna have a review day. Okay. What we're gonna do in the review day is we're gonna go through the practice test. But what I'll do is I'll post the practice test ahead of time, and then for one completion mark, right, which I'll count as an assignment, you can show me that you have attempted the practice test, okay, and that'll count as a 100% assignment mark. Okay. So those are kind of easy marks. I'm not expecting your practice test to be correct, just complete. Okay. Show me that you tried it, you spent time on it, not necessarily that you have complete mastery of everything. I'm not looking at your answers. I'm just looking at, did you try anything? Did you practice anything for this review session? And I find that that's helpful just because then if you've tried it, then you know kind of, oh, okay, I had a hard time with this one, or I had a hard time with this one. And then when we go through it together in class, it'll hopefully make a little bit more sense. So in the review session, I do like to kind of well, we go through the practice test, of course, but I'll also highlight, okay, well, how could this change or how could that change? And think about this, think about that kind of thing. So I kind of give you pointers. Okay. Oh, any questions? No? Quiet bunch. I'm kind of like, what's going on out there? All right, yeah.
So the Zoom will just be strictly live, and then some Zooms you can go back into, but in this case, we'll use the YouTube. Okay?
Yeah, so it's because I'm cheap and I'm not paying for extra storage. So, so the Zoom videos, I download them and then I post them on YouTube instead. Otherwise, I had to pay more. Yeah. But yeah, so the room is always open, but I'll only be there during lectures. Yeah. But I do use the same room for all my lectures, so if you want to join in on stats, you're welcome to. But probably not. Okay. Any other questions? Okay. So because this course kind of takes you from different, I don't know, math places, right? I like to spend the first chapter and kind of really make sure that we're all on the same page. So if you are really strong in math, then that's great. Good for you. Kind of sit back, relax. But after chapter 1, these are all things that I'm expecting you to just know, okay? But I do take my time and kind of walk through, so we'll talk about things like BEDMAS and fractions and all those things that we'll need, okay? So nothing to it but to do it, right, guys? Did I forget anything? I had my list of things, but I talked about all of them, so I wouldn't forget. Maybe I forgot to put something on the list. We'll see. Yeah. So section 1.1, we are pretty well going to cover everything in this book, which as a student, I would have really liked, because sometimes it's hard to have a textbook where you're not sure if everything's going to be covered or if you shouldn't be reading something. No, you can read all of it. It's okay. And so once you get the textbook, then, I don't know, for this week, maybe flip through chapter 1, try all those practice problems, and if they're flowing fine, then you're kind of good to go. Okay? But I won't be getting you to hand anything in or anything like that for chapter 1. Okay, so we'll start with order of operations. BEDMAS, ring a bell? So I guess I better make sure I'm not covering my text. Oh, like I said, I'll only stand on the first day because I like to kind of try to see some faces, and then I'll get lazy and I'll just sit and write. My writing gets better, but I'll be hiding out down here. Kind of boring. But I find I usually kind of jump up more often than not. So BEDMAS tells us the order of our operation or of our calculations. Brackets, exponents. Exponents are just powers, right, guys? Division, multiplication, addition and subtraction. Subtraction. Ugh. So one sneaky part is that for division and multiplication, right, they're kind of best pals, right? One's the opposite of the other. So for division and multiplication, you do whichever comes first, reading left to right. And so not necessarily strictly in this order, right? So they're kind of on the same playing field, right? But that would make a weird acronym, right? And same thing for addition and subtraction. Those guys are best pals too. And so one's the opposite of the other, right? And so it's whichever comes first, reading left to right. Yeah. So I'll do a little. If there's both, division or multiplication, I'll put in brackets, or addition or subtraction, do the calculations in the order they appear, from left to right. Fair enough. Any example that I do are just examples out of the textbooks or out of the textbook. So I'll give you I'll always give you the number. We'll start at example 2. A good place to start. So for example, if we have something like z equals 2 minus 3 plus 6 divided by 3 plus 1 times 9, and I asked you to solve for z, right? We would have to use BEDMAS. Right? So first thing we need to do, right? We have brackets. So right away we zoom in on the brackets, right? And we have to deal with what's inside the brackets first. Okay. Of course, BEDMAS applies inside the brackets as well. So if there's more brackets inside the brackets, you have to deal with those and then kind of blossom out. Okay. So we've got, so the only thing that we're dealing with on this next line, right, is the brackets. Okay. And inside the brackets, we just have 3 plus 6. Right? So we can just simplify that and say 2 minus 9 divided by 3 plus 1 times 9. Oh. So now we've dealt with the brackets. Right? Now we need to look for exponents. Do we have any powers in here? No, we don't. Right? So now we need to look at division or multiplication, right? Remember, they're on the same level. Okay? So we've got division here, but we also have multiplication here. Right? And so remember, we just do them in the order that they appear. Right? And so we've got division first, so we're going to deal with that division first. Okay? And so here, I'll do a little play-by-play. First, we did the brackets, then we did the division, or we're about to. So 2 minus 9 divided by 3 is 3 plus 1 times 9. Now, and we could have dealt with this multiplication on the same line, right? But I want to highlight the order that we would do them, right? It's the order that we would appear, and so, or that they would appear. So next thing we're going to deal with is the 1 times 9, right? We've got multiplication in there. 1 times 9, luckily for us, is just 9. Now we've got subtraction and addition. Again, we just do them in the order that they appear. We can do them just in one go, right? But just to really break it down, I'll do them in 2 steps. But of course, you're allowed to just, well, I wouldn't even mind if you moved from here to the end. Okay? One minor pet peeve that I have is when people don't stack their equal signs. So I want you to try to stack your equal signs whenever you can. Okay? Sometimes even I can't do it just for space issues, but whenever you can stack your equal signs, it's a good thing. Okay? So, 2 minus 3. Breaking them up into itty bitty steps. 2 minus 3, -1, plus 9, 8. Say that again. Oh, you can, yeah, you can just do it right across if you want to. That's fine. Yeah. At this point, when there is only addition and subtraction, it doesn't matter, right? As long as you're doing them kind of from left to right, you're safe. But when there's kind of division and multiplication in the mix, you don't want to jump the gun, right? But definitely, yeah, you could have gone from here to here. Okay. Cool. Any questions? Okay. So like I said, just kind of ironing out all the kinks. How about example 6? So we've got 72 divided by 3 times 2 minus 6. And we just want to solve this. I like to throw an equal sign after. This equals something. Okay. And so we have brackets. Let's deal with those first. So we've got, this is 72 divided by, and in the brackets, we have 3 times 2, which is 6, minus 6. Okay. Because of BEDMAS, right, it's really important that you do 72 divided by 6 first, right? Because what would happen if you did 6 minus 6? and then times that by 72, you'd be at 0, right? And that's not the answer. Okay? So it's important that we do the division first, and then we can subtract 6. Okay? 72 divided by 6 is 12 minus 6, which puts us at 6. Of course, I'm expecting you to use a calculator. I, for one, am not good at math. I repeat, I'm not good at math. This kind of head math, no way. I think it comes from doing too much math. I know the mistakes I'm capable of making. And so I just always use my calculator. Almost embarrassing considering I teach math. But, so I'll always use my calculator. I'm not expecting anything to be done in your head. Okay? Let's do another one. Example 7. Finally, an exponent in here. 72, so it's going to be very similar. 72 divided by 3 times 2 to the power of 2, right? 2 squared minus 6. We have to solve this. So again, we're going to use, do the brackets first, right? But now inside the brackets, we have this power that we need to deal with first, right? The exponents, right? So inside the brackets, we apply BEDMAS again, right? And there's no brackets, but there is an exponent. So first we need to simplify that before we can multiply it by 3, right? So this is going to be 72 divided by 3 times 4, 2 to the power of 2 is 4, minus 6. Now we just have 3 times 4 in the brackets that we can deal with, right? So now we have 72 divided by 12 minus 6. Again, we have to deal with 72 divided by 12 before we can subtract 6. And so we get 6 minus 6, womp womp, 0. Any questions, comments, concerns? None of the above. Nice. Then I guess you won't mind example 8. Example 8 is $500 times 1 plus 0.06 divided by 2, all to the power of 10 minus 1, all over 0.06 divided by 2. So lots of brackets, we've got exponents, we've got division galore, in fact, right? Division. Okay. So we kind of need to boil this down, right, to something manageable. Okay. And this is going to become a very familiar equation that we'll work with. Okay. And so this is where I'm expecting you to be kind of operating later on. Okay. So that's why we take the time to develop all these methods. Okay. So first, I just want to mention some terminology because I do assume that you know that this is a fraction, right? In general, this is a fraction, and we'll talk more about fractions later. But a fraction has a numerator and a denominator. Okay? So because I'll use those terms already right before we've introduced them, just wanted to make a note of that. Okay? In fact, I'll make a little note. Is this going to be too light on here? No, but it looks about the same. Fraction has a numerator over a denominator. So I'll use those terms. I used to have a heck of a time remembering which one was which until I decided that, well, of course, the numerator is on top because he's numero uno. It's on top. So the numerator goes on top, and then, you know, the denominator is on the bottom. Okay? So, all right, let's FEDMAS this beast. Okay? So we've got this 500 outside. That's okay. We'll ignore that till the very end, right? Because we've got brackets. So we start with our brackets, and then we go inside our brackets and see this whole mess. Right now we have more brackets. So then we zoom in on those brackets. Right? So we're going to have to deal with these brackets first. Right? And inside those brackets, we have 1 plus, so we have addition, but also we have division. So we need to deal with this division first before we can add it to 1. Okay. So I'll just kind of highlight the changes as we're going. So we've got our 500 hanging out here. And as we go through and show our work, the only thing that's changing, right, is the one little thing that we're calculating. Right? Everything else you can just write it out the same way, which feels tedious, but that's just how it is. 1 plus 0.03 to the power of 10 minus 1 over, and you've got options here. So one thing that we do is you're going to simplify the numerator separately from the denominator, right? And so I'm always tempted to, right, there's no brackets or anything. I know that 0.06 is just going to boil down, or 0.06 divided by 2 is just going to boil down to 0.03. I'm just going to do it right away. If you want to keep it proper, you can keep it till the end. It's 2 more characters that you have to write. So think about that long and hard. But I'm going to simplify the denominator. I will make a note about that here, though. Okay. So I'll just say we don't need to simplify the denominator until later. But because we simplify the numerator and the denominator separately, it's fair game. Okay. Just saves us a little bit of writing. Oops. So now, right, going back to these brackets here, now we can do 1 plus 0.03. That's an easy change. So we've got 500 times 1.03 to the power of 10 minus 1 over 0.03. It's looking better already. Oh, of course it is. Don't worry, usually lasts a little while. Okay. So what's the next thing we have to do? Now we have to deal with, these brackets aren't necessary, right? Because they're just wrapping up one number, right? I like to have it on there just for emphasis with the power, right? But they're definitely not necessary. Okay, so next thing we have to do is deal with the exponents. Right? So we've got this exponent, so 1.03 to the power of 10. Oh. Guess I should highlight like I said I would. So we've got 500 times, and here's the pickle. Okay. Well, one, if you're using this one and it's just brand new, we'll program them on Wednesday, but it'll just show 2 decimal places. Okay, so I'll show you how to change it to 9 decimal places on Wednesday, when you'll have your new shiny calculators, maybe borrowed calculators, who knows. Okay. We'll get them all set up, but you'll want to make sure that it's showing 9 decimal places. One thing that I want you to be very careful with, right, is that 1.03 to the power of 10 becomes 1.34391, oops, 6, 379. This one. You can't round this number. Okay. What we need to remember is that in the end, we're talking money here. Okay. And so rounding this value would give you the wrong dollar amount. Okay. And it is actually quite significant. Okay. So what I want you to do is whenever you have a value like this on your calculator, right, I'll show you later how to store it. So you can just store it in a value and then you can just recall it. Okay. Or just have it on your screen, right, just like this, and then subtract 1. And then we all knew where this was going. I didn't blow anything today. Right, subtract 1, divide by 0.03, multiply by 500. I think once we get here, we're all kind of okay. Right. But so important thing is don't round these values. Okay. Even if you enter all of these ones, right, your answer will be slightly different still from just keeping it in your calculator, right? Because your calculator remembers more decimal places than it's showing. Okay. So, next thing. Do. Right, we've got 1.34 whatever minus 1. So now we have 0.34391639 over 0.03. Now both the numerator and the denominator are reduced, right? They're simplified. So now we can do that division. So we've got 500 minus 1 divided by 0.03 times 11.46387931. And again, you'll want to keep all these decimal places. Right. times it by 500, home stretch here, right? There's only one thing to do, right? Multiply our $500 by this 11.46, whatever. $5,731.939656. It's kind of gonna go two ways. Okay. Here, I'm saying don't round, keep all your decimal places. Right? Whatever you do, don't drop any decimal places. And then when we're talking about money, I'll be kind of, well, it's money. We have to have just 2 decimal places, right? And so money will always round to 2 decimal places, but often that's not until the very end, right? So there's kind of a, right? These aren't money amounts yet, right? We're multiplying them by money, right? So money has 2 decimal places. Any other values, you keep as many decimal places as you can. And I know that's kind of, what do you want? Pick a lane. Okay. So, so we would say 5,731.94 pennies with proper rounding. Right. 3 is followed by a value higher than 5 inclusive. So we round up. If here you had rounded to 1.34, for example, right? And you had just dropped all these values. Okay. If we had rounded, what is that, 1.3 to the power of 10 to be 1.34, okay, our answer would be $5,666.67. Which one would you rather have? Well, I'd rather have someone who knows how to not round numbers doing my accounting, but right. And so I think that this is kind of a big difference, right? So even just dropping these little, right, and that's keeping 1.34 and just dropping these guys, right? So you can imagine how big of an impact it has if you're not multiplying by $500, maybe you're multiplying by $500,000. It's a little sticky, right? So you want to keep all those decimal places until the very end, right? And only round for money amounts. Okay. So in general, always keep as many decimal places. Always keep as many decimal places as you can. Okay. Only money should be rounded. Right, and I'll put in brackets to 2 decimal places. Uh-oh. I need to give it a little jump start here. So there are kind of ins and outs, right? Money you'll round to 2 decimal places. Everything else, I'm expecting you to keep all your decimal places. And like I said, once we get going using the calculator, I'll show you how to store values. That's going to be really handy, right? Because then you don't have to keep typing all these things in, right? You can just say, oh, remember this. Great. And then use it later. Yeah. So, any questions? I'd say that's about as big of a calculation that I'm kind of expecting you to handle, but I am expecting you to be fluent in handling those equations. Right? So you want to make sure that you brush up on your order of operations, right? I don't want to see any illegal math out there. Illegal math is, well, any illegal math. Not following bad math, dividing by 0, that kind of thing. So there's lots more practice problems. I'm just flipping through here. As a quick kind of check-in, right, there's suggested exercises on page 16, and these I'd say should take you no more than half an hour to get through all of these, right? They should just kind of come to you naturally, okay? So if you're not there, then we need to work on those, okay? And so I kind of need you to be math fluent, okay? So, any questions? Let's see if this charged enough. So we'll also be dealing a little bit with variables. So a variable is just a placeholder for a number in the future, right? And it's just denoted by a letter. Okay? So we have to be able to deal with variables as well as numbers and the two coexisting. So a variable is a placeholder for a number, usually denoted by a letter. For example, 7a. A is the variable. Seven is what we would call the coefficient, right? It's the coefficient of A. So variables are handy, right? Because there's a booby trap up here. Thanks. Should remember that. I almost fell, but I realized it. Right, so A is just a placeholder for future values, right? And so maybe it changes by day, maybe it's by hour, every minute it changes. I'm thinking maybe things for stocks, for example, right? A just kind of changes. 7 stays the same, and it's constantly multiplying A, right? And it might change. Okay. If we have an expression with variables, right, then to simplify those, we have to collect like terms, right, which probably rings a bell at some point in your math career, okay? But we'll just review it quickly. So to simplify an expression with variables, we need to collect like terms. meaning A's go with A's, B's go with B's, C's go with C's, right? And then we can collect all those coefficients, right, and simplify those coefficients. A's go with A's. A squareds go with A squareds, etc. And then we can simplify by collecting the coefficients, right, of the like terms. Simplify by collecting the coefficients of the like terms. Show by example. So solve for A. If A is 60 plus 4 divided by 4 minus 3A. Hey, this isn't what I wanted to do. Oh well, we can do it. I'll do what I wanted to do after this. I wanted to collect like terms right away. It's okay, can deal with just this little variable. Okay. I guess we've got a little a over here that we have to deal with. So bed mass still applies, right? Bed mass is kind of like gravity. It's always there, right? And so we've got brackets. We're going to deal with those brackets first, right? And at some point, right, we'll want to collect these A's so that they're together, right? And then we can simplify by collecting the coefficients. Right? And so we've got A is 64, right? 60 plus 4 divided by 4 minus 3A. I'll do the little highlighting thing. Because I smudged out the 6 earlier. Okay, so we added 60 and 4, and then now, right, we've still got, so we've dealt with our brackets, right? Now we have division and subtraction. We have to deal with that division first. And so 64 divided by 4, oops. The next thing, A is 16. Oops, oops. I forgot the A on here. Got sloppy. If you wanted to move the negative 3A over to the left-hand side right away, go for it. Okay. I want to show just kind of one way to do this, right? There are sometimes situations where, oh, you could have done that at the beginning or something like that, right? But I'm just leaving it there, hanging until the end. And now I'm going to collect my A's. And so to move this negative 3A over to the other side, right, I have to add 3A to both sides, right? Moving it from this side to that side. And like I said, so multiplication and division, they're best pals. Addition and subtraction, they're best pals, right? So they're the opposite of each other, right? So if you're subtracting over here, to move it to the other side, you have to add it to both sides, right? It's multiplying, you have to divide it by both sides. Okay. And so now we're going to take this guy, move it over here. So we have a plus 3a is 16. So now we have just a and 3a, they're both a's, so we can just deal with the coefficients here, right? This is technically 1a, right, plus 3a, so now we have 4a over here. So we have 4a is 16. Our whole goal of this was to solve for a, right? And so here we've got 4 times a is 16. And so we want a on its own. So to move the 4 over here, we have to divide both sides by 4. And so we're going to move this to this side. So I'll just show 4a divided by 4 is 16 divided by 4, right? And 4 over 4 is just 1, and so you're just left with your a. And then we have 16 over 4 is just 4 again. I would not expect you to show this many steps. I want to see some work, but not this many. Okay. And as long as you got to a equals 4, you did it. Okay. Whether that be moving the 3a over immediately, right? First looking at this and saying, okay, I got to collect my like terms and then I'll deal with the rest, or kind of whittling down the first bit and then collecting your like terms, it doesn't matter. Okay. So a lot of illegal math that I see is when we don't do the same thing to one side that you did to the other, right? So a lot of the time I see 4a divided by 4, that's great, but that equals 16. No, that equals 16 over 4, right? And so that's what I mean by illegal math. If you don't do the same thing to both sides, that's a very common illegal math thing to do. Okay. So I'm going to make a note of it. So when working with equations, whatever you do to one side, whatever you do to one side, you must, I'll even capitalize it, you must do to the other side. Otherwise, right, the equality would be lost. An equation, by definition, is something with an equal sign, right? That's what makes it an equation. Okay. So if you're not doing the same thing to both sides, then they're not equal anymore, right? That's a problem if you have an equal sign in there, right? And so I'll add that. Otherwise, the equality will be lost. Okay. How about another example? Solve for x. If we have 3x plus 2y equals 10x minus y. So now we've got two variables, right? each of them appearing on both sides. Right? Got an x and a y on the left-hand side, an x and a y on the right-hand side. Right? I could ask you to solve for y, right? I'm just, in this problem, I'm asking you to solve for x. So x will be in terms of y here, right? And so what we have to do, right, is we have to kind of figure out which side we want to move things. And it helps that if you've done some practice, right, to kind of be able to look at, well, for example, moving this 10x over here makes me deal with a negative. I don't know how you guys feel about negatives, but I don't like them. So all my calculations are kind of, I try to avoid negative numbers whenever I can. Okay. But it doesn't matter which side you put the x's on. Okay. What you want to do, though, is you want to get x's on one side and y's on the other side. Right? We're solving for x, so we want to get x on one side and everything else on the other side. Okay. So doesn't matter which side you pick. Which did I do here? I moved my x's to the left. Oh, big mistake. Let's do it anyways. Doesn't matter. Means I have to deal with a negative, but oh well. So I'll just make a note here. We will move x's to the left and y's to the right. But it doesn't matter, right? Which side you move things to, in the end, won't matter. As long as your calculations are all good. I think I know what happened here. When I decided to move the x's to the left, it's because, well, one, I don't like negatives, but the only time that I would overlook negatives, having to work with negatives, I like to have what I'm solving for on the left-hand side, everything else on the right-hand side. Personal hang-ups. Okay. So now that I've made this little blurb, I'm just going to copy down this equation so that we have a blank slate. So we have 3x plus 2y is 10x minus y. Okay. So I'm going to start kind of collecting all my like terms. So move the x's to one side, the y's to the other side. So this 10x is going to move over here. And you know what? Yeah, let's kick it up a notch. I'll move the y over in the same move. Okay. Wild. Okay. So to get the 10x to the other side, we have to subtract 10x, right? So we've got 3x minus 10x is negative y minus 2y, right? To move the 2y over to the other side, we have to subtract 2y from both sides. And remember, this negative is attached to the y, right? Or the subtraction. So we get negative y minus 2y. Okay. So now we can collect these like terms, right? We've got x and x. Here we've got y and y. So we can just work with the coefficients now, right? And say, okay, well, this and this, because they're on opposite or on both sides of the equation, we can work them over kind of independently, if that's safe. It's when they're in the same equation that it's trouble. So we've got 3x minus 10x. So we've got negative 7x equals, And then negative y minus 2y puts us at negative 3y. So now, right, we could just as easily solve for y as we can for x, but the question said to solve for x, right? So that's what we're gonna do. So to shake out just x on its own, right, we have to divide both sides by negative 7, right? So I kind of imagine holding the x still and then move that negative 7 over. So we've got x is negative 3y over negative 7. Whoa. Oh yeah, yeah, it'll be, yeah, it just depends on where you started, right? But yeah, it would all work out. So if you have two negatives, right? Negative here, we can just cancel those out, so they're positive. So now we have x is going to be 3y over 7. And I would just leave it at that, right? I wouldn't bother simplifying 3 over 7. Cool. Yeah, so it shouldn't matter which side you moved your x's and your y's to. In the end, you should have x is 3y minus over 7. Cool. Any other questions? Okay. How about if I asked you to combine like terms? So not solving it or anything, just combine all these like terms. So we've got 1.0164x plus 1.049x minus x plus 3x squared minus x squared plus 5x squared. Well, it's a mumbo jumbo, but not too bad once we start looking at what variables we have. Right? So we would just read through these and identify the new variables as they come up, right? And so ignoring the coefficients, we've got x, we've got x, we've got x, right? So these are all like terms. And then we've got x squared, okay? Then we've got x squared, and then we've got x squared. Not too bad. So for like terms, right, these are all like terms, and then these are all like terms. So to combine these, right, we just work with the coefficients. Right? As long as we've identified that, okay, we've got x and x and x, then we can just work with the coefficients and ignore the x's. Okay. And so we get this equals 1.0654x plus 7x squared. The reason being is that we have 1.0164 plus 1.049 minus 1, right? Pretty common mistake I see is that we forget that this x actually has a coefficient of 1, right? We just kind of ignore it, but we have to remember to subtract that 1. Easier to look at these ones and say, okay, well, that's 3 minus 1 plus 5, right? 7. So doesn't really apply for this course, but for life in general, it's a good idea to get in the habit of writing polynomials like this. So this would be a polynomial, right? 1, 2. If you have more than one variable, it's a polynomial. With increasing coefficients, or decreasing coefficients, I should say. Okay. So just make a note. I only make a note of it because it's going to come in handy just briefly later on, right? Where we kind of want to have them written in order. Okay. And so that's the only reason that I mention it. Okay. So it's a good idea to get in the habit of writing expressions with decreasing powers. So then our answer would be, it'll be the same, right? But just 7x squared plus 1.0654x. About another example. Example 14. If I asked you to solve for x in this equation. So we've got 25,000 equals x plus x times 1.05 to the power of 1 plus x times 1.05 to the power of 2 plus x times 1.05 to the power of 3. So again, right, we've got money on this side, right? But these values are just numbers, right? So that means that we have to keep as many decimal places as we can, right, in our calculations. So one kind of sneak attack thing that we can do is, because we've got exponents here, these brackets don't really mean anything, right? Because they're not doing anything, they're just wrapping up a single number. But like I said, I like to throw them on there when there's powers, just to kind of highlight that, hey, this is to the power, this is all to the power of 2, for example. Okay. They're not actually necessary. Right? So we have brackets, but they're kind of fake. But we do have exponents, right? So we need to deal with our exponents first. But because they're kind of standalone things here, we can do them all in the same step. Okay? So what we're going to do here is we're going to deal with this, this, and this all in one go. So we've got x plus 1.05 to the power of 1 is just 1.05. And we have x times 1.05 to the power of 1. But now that we've narrowed this down to one number, I prefer to have it in the front like a coefficient, like a proper coefficient. Again, it doesn't actually matter, right? They're being multiplied. The order that you multiply 3 times 2 is the same as 2 times 3. Right? So it doesn't matter, just for looks, I guess. So we've got 1.05x 1.05 to the power of 2 is 1.1025 times x plus 1.1025x plus 1.05 to the power of 3 is 1.157625 times x. And now I can collect all these like terms because they're all with x's. And so forget this 1x, right, as a coefficient of 1, right? 1 plus 1.05 plus 1.1025 plus 1.157625. Because I have this biggest one on my screen already, I'll start there, kind of work my way through these, right? So plus 1.1025 plus 1.05 plus 1. So I get 4.310125x. One thing that I try not to do actually, because I think it throws people off, but I just leave it. If nothing's changing on the left-hand side, you don't have to write it out a bunch of times over, right? It's just assumed that it continues. Okay. But so now we can kind of jump in and say, well, 25,000, remember that's what it's equal to, is 4.310125x. The whole goal was to solve for x, right? And so we need to shake the 4.31 off the x. So we need to divide both sides by 4.31. So we need to divide 25,000 by 4.31, whatever. So we've got 25,000, divided by 4.310125. So we've got 25,000, one too many zeros, I think, divided by 4.310125 is x. Remember my urge to put whatever I'm solving for on the left-hand side, right? What I often do is I'll just, in this step, I'll just put x on the left-hand side, put this on the right-hand side. They're the same, right? A equals A equals A. It's the same. And so x then is going to be 5,800.295815, but with proper rounding, x would be $5,800.30. Cool. So I think that's enough math for today. But do go and acquire a textbook, okay? And make sure that you do just rip through these practice problems on page 16. Okay? And just make sure that those are all under control. Okay. And then if you want to read ahead, we'll kind of plow into chapter 1 for next day. Potentially finish it next day. See you guys on Wednesday. Oh, any questions before I let you go? It's a little late, I guess.